Hi students! In this video we're going to be solving advanced abstract equations, and then we'll move on to some word problems and quadratic equations. So we remember that equations contain many variables and that have no numerical answer. Those are the abstract equations, okay? And so what we want to do is, in order to solve this kind of equation, we want to multiply by the least common denominator, okay? So if you think about least common denominator, that would be x times m. And so that's what we want to do, multiply each one of these terms in the equation by xm. And that way we'll get rid of fractions. So xm, we're going to multiply that by a plus b over x, okay? And I think they go ahead and put parentheses at least around this one. And again, xm, y over m, okay? And then we have xm times k, okay? So we've multiplied by the least common denominator, and now we're going to cancel some things. So notice there's an x on the top and the bottom of this. So we're going to cancel that out, and we're left with m times a plus b. On this one, we can cancel out the m's. So we're left with xy. And on this last part, we can't cancel out anything, so we're just going to say xmk. All right. Now they want us to solve for m, okay? So what we could do is we could distribute this through, okay? And then we're going to have ma plus mb plus xy equals xmk. So I just went ahead and distributed it through. And now in order to solve for m, this is where it's a little bit different from maybe what you've done before. We have to get all of the terms with the m's on one side, and I'll show you why we're going to do that. The reason we're going to do that is we want to be able to factor out an m from everything. And when we do that, we're going to be able to divide by what's multiplied by m after that, and we can get m by itself. So I'm going to go ahead and subtract this from both sides to get it over here. And then I'm going to subtract this from both sides because this doesn't have an m in it, and that will move that over on the right side. So let's do that. So I'm going to do this over here. I'll just kind of do it off to the side, but I'm going to write these first. So ma plus m b minus xmk, and right now we have plus xy equals 0. That's what we have right now. Then we're going to subtract this over here on the right side, and again that's going to get all the stuff with the m's on the left, and this will be on the right side that doesn't have any m's in it. So now, what I was saying before is we're trying to solve for m. So what we can do is factor out, pull out that m, okay? So let's factor out an m and write what's left. So if you think about dividing each of these by m, that's what would be left when we put it in the parentheses here. So if we factor out an m, we are left with a on this term. We're left with b on this term, and we're left with xk on this term. And now we're getting somewhere. So now, in order to solve for m, note that this is m times all of this. All I can do then is divide both sides by all of this, and I'll get m by itself, okay? So I'm going to divide both sides by this a plus b minus k, okay, a plus b minus xk, and I will end up with negative xy on top over, and I'll just go ahead and take the parentheses out, a plus b minus xk. And so now I have solved for m. So there's another example just like that. And then there's one more example that we can do before we move on to the word problems and quadratic equations. So this, I'm going to go ahead and skip to the third example in this book because the second one is very similar to what we just did. And so this is mx over y plus d over a plus b equals p. So for this one, they want you to solve for a. So we begin by multiplying every single term by the common denominator here, the least common denominator, which would be y times a plus b. So we're going to do y times a plus b. So we can kind of do like if we did y times a plus b for each of these, I'll just write this over here. That's what we're going to multiply every single term by. So if I were to write that, I could say ymx times a plus b. I'm just putting what's already there out in front, so I don't have y and a plus b and then mx after it. I'm just putting it all out in front. And then that would be all over y. This would be yd times a plus b all over a plus b. And this one, we don't have to worry about anything on the bottom, but it's just, we can say yp times a plus b. Now let's go ahead and cancel things out that can be canceled. So you see that there's a y on the top and the bottom. So now we're left with mx times a plus b. Here we can cancel out the a plus b. So we're just left with yd. And then over here we do not cancel anything. All right, so again, this is going to be the same strategy that we did on the last one. We're going to go ahead and distribute. And then since we were wanting to solve for a, we have to collect all the terms with the a's on one side and get everything else on the right side. We'll collect the a's on the left and get everything on the right, else on the right. And then we're going to divide, after we factor out our a, we're going to divide by what's left on both sides, okay? So here I go, distributing mxa plus mxb plus yd equals ypa plus ypb. And I know that these are out of alphabetical order. I normally am a real stickler on that, but just for the sake of showing you I'm just distributing, I'm not going to put them in order right now. So now, like I said before, we're going to collect all the ones with the A's on the left, and we're going to move all the other things that don't have A's on the right. So I'll start by subtracting YPA. And the reason I'm kind of moving it off to the side here is because it doesn't have a like term over here, so I don't want to put it underneath one of these to show that it's, sometimes that indicates that it's a like term, and I don't want to do that. So I'm kind of moving it off to the side here. So we have, I'll put this positive one first, MXA minus YPA plus MXB plus YD equals, this one cancels, YPB. And now I'm going to move both of these over on the right side. I'm actually going to do that in one step here. I'm just going to show that I'm subtracting both of them from the left. I'll subtract both of them from the right. Okay, and again, I'm moving them off to the side because they're not like terms with these other ones. So now I have mxa on the left minus ypa. These are gone now on the left. And that equals ypb minus mxb minus yd. So, we're almost done. We have to factor out our a. So we're going to factor out the a. When we do that, we're left with mx minus yp. And that equals all the stuff on the right. So I'll write that down. And then the very last step is that to get a by itself, we can divide by this. Okay? So we'll divide by mx minus yp. This time I won't put parentheses around it. So now those cancel, and look, a equals that mess. So, and I think in your book, again, they don't really put it in alphabetical order either. So, I mean, you can put it in alphabetical order if you want, or you can just leave it like this. Again, I'm so used to putting it in alphabetical order, but this book sometimes just doesn't. So now I'm getting, kind of used to that. But that's the final answer or version of that. Again, they might have BPY. You might want to put them in alphabetical order, but you don't have to. So that is the answer for that problem, solving for A. The very final example that they give you here is relating to word problems and quadratics. And so for the example 4 in the book, they say find 3 consecutive integers. So I'm going to write that down. 3 consecutive. That means they're 1 apart. They didn't say odd or even. They just said 3 consecutive. So they're 1 apart. So we're going to say the first one is n, the next one is n plus 1, the one after that is n plus 2. So write down however many you have. So it says they have 3 consecutive integers such that the product of the first and the third is, so that we're going to say the product. Product means multiply. So we're going to say the product of the first and third. So we're going to do n times n plus 2. So the product of the first and third is equals, and it says here 4 greater than 4 times the second. 4 more than or greater than. And then it says 4 times the second. The second one is n plus 1. So this is what you have. So you have to write your equation correctly, translating from words to the math. And then from there, we're able to distribute. And this is where the quadratic comes in. Notice if we distribute n times n, you get n squared. And then n times 2 is 2n. And then we have 4 plus 4n plus 4. So we have that. And what they want to do, being as we have a quadratic here, we're going to have to get everything over to the left side, get a 0 on the right side, and then we can factor. You could also use the quadratic formula if you wanted to, but in this case, it's going to be nice enough to where we can factor. So I'm going to subtract. Well, first of all, let's combine. So we have 4n and then plus 8. And then we can subtract the 4n. So we'll have n squared equals, n squared minus 2n equals 8. And then the very final step is subtract that 8. And I'll do it kind of over here. Again, I don't want to indicate that it's a like term with the other ones. but I'm going to write n squared first, minus 2n minus 8 equals 0. And now I'm going to factor this. What two numbers when multiplied give me a negative 8, but when added give me a negative 2? So two numbers that when multiplied give me a negative 8, but when added give me a negative 2. Which two numbers are 2 apart, you could even think, that are factors of 8? That would be a 4 and a 2. So I'd say a 4 and a 2. And because I want a negative 2, I need the 4 to be a negative and the 2 to be a positive. And now from this point, I can set both of these equal to 0 and solve. So I've got, if I add 4, I get n equals 4. If I subtract 2, I get n equals negative 2. Those are my two answers. And so this is interesting. We have actually two sets of answers here. So for our integers, if we think about going back to the original problem, they wanted 3 consecutive integers that match the description. It says the product of the first and the third is 4 greater than 4 times the second. And so we actually have two sets of integers here. If the first integer is 4, if n equals 4, then n plus 1 equals 5, and n plus 2 equals 6. So that's one combination, 4, 5, 6. And then the other one, if n equals negative 2, then n plus 1 equals negative 1, and n plus 2 equals 0. So you have there two sets of 3 consecutive integers that work.